found it all out, but on how clever she is to pay attention to it. Now, what is this law of gravitation that we're going to talk about? The law is that two bodies or bodies exert a force upon each other, which is inversely as the square of the distance between them and varies directly as the product of their masses. And mathematically, we can write that great law down in the formula, some kind of a constant times the product of the two masses divided by the square of the distance. Now, if I add the remark that a body reacts to a force by accelerating or by changing its velocity every second to an extent inversely as its mass. It reacts, it changes velocity more if the mass is lower and so on, inversely as the mass. Then I have said everything about the law of gravitation that needs to be said. Everything else is a consequence, a mathematical consequence of those two things that I said. That's a remarkable enough phenomenon in itself that the next lecture will consider this in more detail. Now, I know you're not all here. I know some of you are, but you're not all mathematicians, and so you cannot all immediately see all of the consequences of these two remarks. And so what I would like to do in this lecture is to briefly tell you the story of the discovery, tell you what some of the consequences are, what the effect of this discovery had on the history of science, what kinds of mysteries such a law entails, something about the refinements made by Einstein, and possibly the relation to other laws of physics. The history of the thing, briefly, is this, that the ancients first observed the way the planets seemed to move about in the sky and concluded that they all went around, along with the Earth, went around the sun. This discovery was later made independently by Copernicus after they had forgotten, that people had forgotten that it had already been made. Now, the next question that came up to study was exactly how do they go around the sun? That is, exactly what kind of motion? Do they go with the sun at the center of a circle, or do they go in some other kind of a curve? How fast do they move, and so on? And this discovery took a longer to make. The times after Copernicus were times in which there were great debates about whether the planets in fact went around the sun along with the Earth, or whether the Earth was at the center of the universe, and so on. And there were considerable arguments about this. When a man named Tycho Brahe got an idea of a way of answering the question, he thought that it might perhaps be a good idea to look very, very carefully and to record where the planets actually appear in the sky, and then the alternative theories might be distinguished from one another. This is the key of modern science and is the beginning of the true understanding of nature, this idea that to look at the thing, to record the details, and to hope that in the information thus obtained may lie a clue to one or another of a possible theoretical interpretations. So Tycho, who was a rich man and owned, I believe, an island near Copenhagen, outfitted his island with great brass circles and special observing positions, situation chairs that you could look through little holes, and recorded night after night the position of the planets. It's only through such hard work that we can find out anything. When all these data were collected, they came into the hands of Kepler, who then tried to analyze what kinds of motions the planets made around the sun. And he did this by a method of trial and error. At one stage he thought he had it. He figured out that they went around the sun in circles with the sun off center, and noticed that one planet, I think it was Mars, but I don't know, was 8 minutes of arc off, and he decided that this was too big for Tycho Brahe to have made an error, and that this was not the right answer. So because of the precision of experiments, he was able to proceed and to go on to another trial, and found, in fact, ultimately this. Three things. First, that the planets went in ellipses around the sun with the sun of the focus. An ellipse is a curve all artists know about because it's a foreshortened circle, or children know about because somebody told them that if you take a string and tie it to two tacks and put a pencil in there, it'll make an ellipse. These two tacks are the foci, and if the sun is here, the shape of the orbit of a planet around the sun is one of these